Okay, so due to the timeline of when the seniors are going to be done, today you're actually going to do notes and homework because my last day to give you seniors assignments is 27th. So you're going to do notes and homework today. You're going to do notes and homework on Tuesday, and then the exam on Wednesday, and then you guys are done. If you are not a senior, you have the rest of the time to make stuff up. So that gives some of you some time to catch up if you are not a senior. So today we're going to talk about permutations. This is a two-part lesson. So we're going to do one today. We talked about the fundamental counting principle in 11.1. That's when you can just multiply the number of things that occur, and they will give you the number of ways. So in this section, we're going to talk about when order matters. So when you're doing the fundamental counting principle, order does not matter. We will not get to 11.3, but that's combinations. Order does not matter in that as well, but permutations, order does matter. So it says, let's say that you did hit Powerball that we talked about last notes for 1.5 billion, and we decided to start a collection of expensive sports cars. Now we have to decide which way we want to park them in our new mansion's garage. So you have Ferrari, Porsche, Lamborghini, Ferrari, and a McLaren. Order matters. This is how many different ways can you arrange these cars in your garage when order matters. So that's saying that different spots. So you could line them all up in here. You could say this is the, that's super thick. Could say, give me a second. You could say this is the 15 Ferrari. You could say this is the 15 Porsche. I guess they're all 15s. So you can say red Ferrari. They're both red. We'll say La Ferrari. This is the L Ferrari. This is the Porsche. This is the, I'm going to say Lambo. This is the F12. This is the McLaren. So you could have them that way. You could do this for every single one. And you could go through all the different ways you could do this. That's a lot of work. So let's talk about something else. So you could do that, all those cars, and put them in all the different spots when order matters. So this, again, it's saying a permutation is an ordered arrangement of items that occurs when no item is used more than once. So you have to use each car exactly one time. And then the arrangement of order, it makes a difference. So here, it's how many ways can the 5 sports cars be arranged in the garage if you want the LaFerrari in spot 1, so this is in spot 1, and this is in spot 5. So you then have the other 3 cars. So you have the Porsche, the Lambo, and the F12. So we could do this like that: the Porsche, the Lambo, and the F12. You would keep everything the same. So this is why. The next day you could do the Porsche, the F12, and the Lambo. Number 3, you could do the Lambo, the F12, and the Porsche. You could do the Lambo, the Porsche, and the F12. And then I'm going to do it the same thing over here. So you have the LaFerrari, and you have the McLaren. So number 5 would be then, if you put the F12 first, you could then do the Porsche and Lambo. In step 6, you could do the F12, and you could do the Lambo and the Porsche. So there'd be 6 ways to do this, if you're counting the permutations. This is very monotonous. It's not fun. It's very monotonous. So same thing. It's a need to arrange 7 of our favorite books along a small shelf. How many different ways can you arrange the books, assuming order matters? So if you go from so you could do all these. It would take you a really long time. You could go 1, 2, 3, 4, 5, 6, 7. You could go 1 and then put the 3 first. 1, 3, 4, 5, 6, 7, 2. 1, 4, 5, 6, 7, 2, 3. You could keep going on forever and you could figure this all out. That's going to take us forever, which we don't want to do that. So there's something called a factorial. So factorial, I don't know if we get to that. Yeah. A factorial is going to help us with this. So I don't really want to list all those because that's going to take us a really long time considering they don't tell us anything has to stay. So what you would do here is you're really doing 1 times 2 times 3 times 4 times 5 times 6 times 7. This is also known as a factorial. So you can do 7 factorial and you should get the same answer. Up here, really, we were only moving 3 things. So you would do 3 factorial, which would be 1 times 2 times 3. 1 times 2, 2 times 3 is 6. So that's the same thing here. Since we're moving 7 things, you're doing 1 times 2 times 4 times 5 times 6 times 7. That's 7 factorial. Those of you who do not have an actual calculator at home, I have this pulled up here for you. So hopefully you can still see my screen. Go to Desmos.com and then hit start graphing. And it's going to pull you up to a calculator that looks like this. You'll see here in the bottom left-hand corner, there's a keyboard. Open that keyboard up, and instead of going right here, go to the 1, 2, 3, 4. Oh, here we go. I don't know what I just did there. You don't want to 1, 2, 3, 4. I don't know what this is and what that's doing. We need to get this out here. Let me pick up. Start graphing. Okay. Whatever. That thing's gonna just chill here. Okay. Disregard. I don't know what that's doing. We don't need that. Okay. So up here in this box, you're going to hit 7 at the bottom, and you can see it types up there to the left. And then hit ABC, and you'll see that there's an exclamation point. It's going to tell you the answer. I don't think you want to go through all those different ways to order the books. So this, well, I went away, but that was going to be your answer. 7 factorial. It's going to be 5,040. Always. I wasn't going to go through all those. That would be forever. So same thing with this. It says how many different ways can you arrange 10 books assuming that order matters. So you're doing 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. That's 10 factorial. And if you go into that calculator, you're again going to go to 1, 2, 3 now. You're going to do 10 and then you're going to go to ABC, and you're going to hit that factorial button, and you'll get that big number, 3,628,800. So that's a lot of different ways to be able to order those books. So it says we can use special name result in our sports car example. It's called a factorial, and it is written as an exclamation point. In general, if n is a positive integer, the notation n exclamation point is read n factorial. Is a product of all positive integers from n down through 1. So this is 1. This would be 1 times 2, which is 2. This would be 1 times 2 times 3, which is 6. 1 times 2 times 3 times 4. This is going to be 24. 1 times 2 times 3 times 4 times 5. So you're going to do 24. 24 times 5, which is 120. This is going to be 1 times 2 times 3 times 4 times 5 times 6, which is really just 120 times 6, which is 720. So that's how you get those. So it says factorial notation. If n is a positive integer, the notation n factorial is the product of all positive integers n down through 1. That tells you how you could do this. Know if you have 0 factorial, your answer is 1. So value ways. So we just did 6 factorial. 6 factorial was 720. We're just going to evaluate in the calculator. So I'm going to be moving back and forth here. So you have 8 factorial divided by 5 factorial. So in my calculator, I'm going to do 8 factorial, and you're going to go back and you're just going to hit division bar. And on the bottom, you're going to hit 5 factorial, and it's going to give you 336. Same thing for the next one. 26. 26 factorial divided by 21 factorial, and you get a big number, 7,893,600. So it's 7,893,600. And then do the same thing for the last one. So you're going to do 17 factorial minus 12 factorial. 17 factorial minus 12 factorial. This number is really big. So it's 10 to the 14. So that means that you're moving that decimal place 14 spaces to the right. So this is a huge number. So I'm going to say 3.6 times 10 to the 14. If you were to do this, you would have 3, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That'd be how big this number is. So you have hundreds, thousands, millions, billions, trillions. So that'd be trillions. That's a lot of zeros. So that's a big number. We can use factorial notation when we want to rearrange all objects in particular orders. So it's how many different ways can you arrange 5 sports cars in your garage? Well, you have 5 sports cars. That's 5 factorial. 5 factorial, we already talked about. That was 120. But if you don't know that, again, you would go to your calculator, you would go 5, and then you have the exclamation point, and you should get 120. That's all there is for today. So that was short, sweet, to the point. You do have homework today following this video. Do the homework. This will be the same thing on Tuesday. So seniors, you're almost there. 3 class days left. Well, if you count this one. I hope you guys are having a great time at home. I miss y'all.